The next topic we'll be learning about is free energy, which is another type of thermodynamic process. Let's quickly recap all the thermodynamic processes that we've learned about so far this unit. First, we have enthalpy. Enthalpy is the energy of a reaction, and under constant pressure is equal to the heat flow of reaction, or Q equals mcat as we more commonly use it. We've learned about entropy most recently, which is the amount of disorder in a system. Entropy is dependent upon the temperature, and that's the temperature of both the system and the surroundings. We know that the amount of entropy in the universe is always increasing, and we also know that the amount of energy change is always constant. That is to say, the amount of energy in the universe is constant. However, we have one more that we need to learn about, and that's free energy. Free energy is dependent upon temperature, and it's also used to determine the spontaneity of a reaction. Now you might say, didn't we just learn entropy, which tells us about the spontaneity of a reaction? Well, yes, but enthalpy also plays a role into the amount of energy that can be given off from a reaction. So we have to bring both entropy and enthalpy together, and that'll be in this formula. G, which is free energy, is equal to the enthalpy of a system minus the product of the temperature and the entropy of a system. However, energy, like enthalpy and entropy, is a state function, which means that we can use the following formula. Delta G is equal to delta H minus delta Ts. However, when we calculate free energy, we're going to be doing it under constant temperature and pressure conditions, which means that delta Ts can turn into T delta S. And this will be the most common formula form that we will be seeing. Delta G is equal to delta H minus T delta S. We should also note that this is always referring to the system, that is, the chemical reaction that is taking place. So how does free energy relate to spontaneity? Well, let's first start with the equation we just learned. Delta G equals delta H minus T delta S. Let's first divide both sides of the equation by negative T. We then get the formula delta G over negative T equals negative delta H over T plus delta S. And we've learned that that's this entropy of the system. We've also learned that that part negative delta H over T is equal to the delta S of the surroundings. So now we have the sum of the delta S of the surroundings and the delta S of the system, which as we know before is the delta S of the universe. So we can confidently say that the delta S of the universe is equal to the negative delta G over T. Now if we remember, if the entropy change of the universe is positive, the reaction is said to be spontaneous. Since temperature is Kelvin and always positive, that means that when delta G is negative, we will have a spontaneous process. Let's show the relationship between free energy and spontaneity. We just learned that if delta G is negative, we will have a spontaneous process. But how does that translate into calculating for an actual chemical change? Let's suppose we have the following chemical change. H2O solid turning into H2O liquid. We should know that this process is called melting, and it occurs when the temperature is greater than 0 degrees Celsius. We also can look up the delta H of this reaction, which is 6.03 times 10 to the 3 joules per mole, and we can look up the delta S, which is 22.1 joules per Kelvin mole. Now let's take the first situation. The temperature is negative 10 degrees Celsius, which is equal to 263 Kelvin. Now we know at negative 10 degrees Celsius, water as a solid will not melt into a liquid. So if we calculate all the values that we need to calculate delta G, we'll determine that it's 220 joules per mole, which is a positive number, which means this reaction is non-spontaneous. So therefore, we can see that if G is positive, it'll be a non-spontaneous process. And we know that this process is non-spontaneous because water doesn't melt at negative 10 degrees Celsius. Let's take a look at the second situation. So in situation 2, we have a temperature of 0 degrees Celsius, 273 Kelvin. You should know from chemistry class that water can be a liquid or a solid at 0 degrees Celsius or 273 Kelvin. So if we calculate the delta G of this reaction, we determine that the delta G is 0, which means both the forward and reverse reaction occur spontaneously. So this shows us that when delta G is equal to 0, both the forward and reverse reaction can occur. We call that equilibrium. the last situation, when the temperature is 10 degrees Celsius. We know that water melts at 10 degrees Celsius. It'll go from a solid to a liquid. So let's show that the delta G is negative 220 joules per mole. And we know that the forward reaction is spontaneous. So this just goes forward to prove that when delta G is positive, we have a non-spontaneous reaction. When delta G is negative, we have a spontaneous reaction. When we have delta G is equal to 0, we have equilibrium. Hopefully this video helped to show you the relationship between free energy and spontaneity. Be sure to check out Chapter 7 should you have any confusion. Thank you.